Welcome everybody. In this video I will show you how to create a nice and engaging Jumpy Row layout in Jetpack Compose. You can see the preview right here on the emulator. So this magic layout animates its items with running wave animation. I hope you are excited, and let's take a look at the code. So here is the main Jumpy Row composable function, and let's take a look closer at its parameters. First, it has a modifier parameter, which allows us to customize the layout appearance. Then there is two customization parameters for the wave width and the wave height. Both are measured in dps. Then there is also an animation spec parameter of type infinite repeatable spec of type float, which gives us a complete control over the animation behavior. And the last parameter is a content lambda, which allows us to specify the content of this layout. Alright, now let's dive deeper into the implementation of this function. And first, we need to define an infinite transition, which will drive the animation. After that, we use this infinite transition to define a wave progress animation, which runs from 0 to 1, and we also paste the animation spec parameter to that. After that, we use a layout composable function to define a custom layout, and we paste the modifier and the content to that. Inside of this layout, first we need to convert the wave width and wave height properties into pixels. That's what we do. Then we need to measure measurables into placeables, so that later we could place them. Next, we need to calculate a few more properties for the layout. First is a row width, and it's very simple, it's just a sum of all width. But for the row height, we first need to find the tallest item in a row, and we do that with max height, and then we add the wave height to it. Then we initialize the layout with the row width and row height that we have just calculated. Within this layout scope, we first define an X position variable, which will help us to track the X position to place the items in a row. Also, we need to calculate a few more properties for the wave. First, we need a total distance, which consists of row width and wave width. And here I have a picture for you. So, as you can see, here is the row width and the wave width. And together, it's the total distance that the wave should go. Also, we need a wave start, which equals minus wave width, means the initial wave position, plus total distance multiplied by wave progress. And also, we need to calculate a wave end, which is very straightforward. It's wave start position plus the wave width. And we loop through all of the placeables, and for each placeable, first we need to calculate the item center X, which is X position plus half of its width. Then we also need to calculate a base Y position, which equals row height minus placeable height. The actual Y position will be defined based on if statement. So if the item center X is in the wave bounds, then first we need to normalize this item center X from wave start and wave end bounds to -2 and 2 using this normalize X function. And so basically, this function just normalizes this X value from one range, which is original, to a new range, which is target range. For example, if you would have an original range from 0 to 100 and your X position would be 50, means the center, and if you would have a target range from -2 to 2, then your X value will be 0, means the center. And so, why do we use this -2 and 2 here? That's because we will use this bell curve function, and we take a piece of it from -2 to 2 to get this nice bell curve, which we will use to animate the items. Then we paste this normalized X value, which is now from -2 to 2, to wave curve function, which is defined below. And here you can see it again. And as you can see, it will return us a value from 0 to 1. And so we get this wave effect. as then we multiply this wave effect by wave height, and we subtract this value from the base Y position. Otherwise, if the item center X is not in the bounds of the wave, we simply assign it to a base Y position. And finally, we can place the item by using place function and X and Y position. And also, we need to increase the X position by placeable width for the next item. Alright, we are done with this Jumpy Row function. Now let's switch to the main activity and consider some practical examples. So here I have prepared 4 slightly different examples, and we'll go through them one by one. So let's start with the first one. Here we have a Jumpy Row with custom wave width and wave height. And for the content, we loop through symbols in Jetpack Compose string and create a text composable for each of those symbols. The second example is very similar to the first one, but this time we specify a custom animation spec and set the repeat mode to reverse. The third example is the most common one. We don't specify any parameters at all, just repeat those blue sticks 60 times. And finally, we have the fourth example. And for that, we need to use a column to arrange 2 layouts vertically, one on top of another. And then within this column, we have 2 similar Jumpy Rows. Each of those rows have 15 circles, and the top one has magenta circles, and the bottom one has yellow circles. And the one more difference, for the bottom one, we set the scale Y to -1 to flip this layout vertically. Now let me run the application to see the final output. Here we go, and you can see this beautiful output. It's amazing, isn't it? If you enjoyed this video, please go ahead and click the like button down below, leave your thoughts in the comments, and also subscribe for the channel, and I'll see you in the next video.